I can upload the video. All right, so here's the thing. Real quick, I want to do a quick review about triangles. Real quick. Can't do it on my work because my darn board doesn't work, but let's just recap some things that we know about triangles. Not everything we know about triangles, but today's lesson is all about a special kind of right triangle and special relationships that come with that special right triangle. Some things that we already know about triangles is how many total degrees are there in an interior angle of a triangle rather? 180. Right. If it's an equilateral triangle, what do we know about it? What's congruent? The sides are congruent. And the angles. Good job, Shamari. So equilateral triangles are also equiangular. I don't want to write that, but it's going to be in our notes. Equiangular, equiangular. You say tomato, I say tomato. Actually, I don't. I say tomato too, but some people say tomato. All right. An equilateral triangle has all congruent angles. On top of knowing that they're congruent, we actually know what the measure of those angles are. How did you get 60? 180 divided by 3. If all three angles are the same, and they have to be in an equilateral triangle, then they have to be 60. Okay? So all three angles are 60. Can't think of anything else right off the top of my head, but those are some things we need to remember. We're going to talk about them again in the notes, but that's from review. All right? So we're going to learn about several kinds, two kinds of special right triangles. 30, 60, 90 today. Next week, we're going to learn about a 45, 45, 90 degree triangle. What does that mean? I did mean to put that on the board. Okay. So, this is a right triangle, right? A 30, 60, 90 degree right triangle has one angle that's 30, one angle that's 60, one angle that's 90. Not all right triangles are 30, 60, 90 triangles, right? Like I said, next week we're going to learn about this kind of a right triangle. But there are right triangles that aren't like having one of those, right? So if this is 90, let's say this is 40, 90 and 40 is 130, so that would be 50, right? We can have right triangles with different, these other two angles, right? But special ones are these two. And these two come with special rules we can use to figure out things about that triangle. Okay, and we can use those triangles in some of those kind of real world problems sometimes too. All right. So 30, 60, 90 degree triangle just means it is a right triangle. So one of the angles is 90 degrees, one of the angles is 30 degrees, and one of the angles is 60 degrees. Okay. So how do we know which leg? So another thing I forgot to recap really quickly, but it's here. This is a special relationship. We're going to ignore this for right now. Right now, what I want you to look at is the diagram. Okay? We know that the side across from the right angle is the hypotenuse. We know the side across from the 30-degree angle has to be shorter than the side across from the 60-degree angle. We learned that. The smaller angle is across from the shorter side. A bigger angle is going to be across from a longer side, right? So how do we know which leg is the shortest if there is no measure? Well, the side across from the smaller angle is going to be the shortest side. The smallest angle, the smallest, the shortest side, the smallest angle, vice versa.
Do we have to write the question too?
No, you can just write the question. Here's a swap for now. Want yours back, you can just pop it back at the end. All right, the side across from the smaller angle is the shortest. Well, actually, you're going to have to write is the shortest, Sharad, otherwise it won't make any sense there. And we're really only talking about legs We know the hypotenuse is always the longest side on a right triangle. Okay. So that being said, there's a rule that says that the hypotenuse is always 2 times the length of the short leg. So let's say, and you don't have to write this, let's say, what's your favorite number, Jamari?
11.
Let's say that the short leg is 11. Well, now we know the hypotenuse is 22 because it's 2 times the short leg. Okay? Make sense?
Yeah.
Yep. All right. Another part of this rule says the long leg is always the square root of 3 times the short leg. So if the short leg is 11, now we know that the long leg is just the square root of 3 times 11, and we write that as 11 square roots of 3. That's the rule. Everything's kind of in relation to the short leg. Right? The short leg has a special relationship with the hypotenuse. It has a special relationship with the long leg. So far, so good? All right. So I think it's important when you start doing these at first that you go ahead and write down what is the short leg, what is the long leg, and what is the hypotenuse in the problem you're working on. So in this problem here, we know right away that the hypotenuse is across from the right angle, so we can fill that in. And I do want you to write this. If you want to abbreviate, use short, long, and height for hypotenuse. I'm okay with that. The hypotenuse, they're representing the length of the hypotenuse here with the y. Now remember that the short leg is across from the 30-degree angle. So the short leg, in this example, has a length of 3. The long leg is across from the 60-degree angle. So in this example, they are using x to represent the length of the long leg. We like it when they give us the length of the short leg. These are the easiest ones to do, right? So in this example, we need to find x and find y. So if we look at this rule, it says the hypotenuse is, well, the hypotenuse in this example is y. So y equals 2 times the short leg. So y equals 2 times 3, because 3 is the length of the short leg. So you're writing that down.
We just need 6.
So, nope, you're going to write then y equals 6. So now we know the hypotenuse has a length of 6. Looking at our rule here, it says the long leg is the square root of 3 times the short leg. So the long leg in this example is x. So x equals the square root of 3 times the short leg. And that gets written as 3 square root of 3. Like if you're multiplying x times 3, you're going to write it 3x, right? That number on the outside of the square root is the coefficient, so it gets written on the left side. So far, so good? All right. What's that? Okay. So for this example, we see the hypotenuse is 8. Short leg, long leg. So let's go ahead and fill that in. Short leg across from the 30-degree angle is x. The long leg across from the 60-degree angle is y. And the hypotenuse is 8. So we always need to be working with the short leg. There is no special relationship that we're working with between the hypotenuse and the long leg, right? So if we know the hypotenuse, we're going to use that to find the short leg. Remember we said the hypotenuse is 2 times the short leg. So in this case, the hypotenuse is equal to 2 times x, because x is the short leg. Now, I wrote an equation here and solved it. But you can just remember that if you know the hypotenuse, you divide by 2 to get the short leg. If you know the short leg, you multiply by 2 to get the hypotenuse. The hypotenuse is always twice the length of the short leg. Does that make sense, Dominic? Okay. Once we have the short leg, now it's a fair amount easier to get the long leg. The long leg, y, is always the square root of 3 times the short leg. The square root of 3 times the short leg. So that's what we're going to do. Square root of 3 times 4, and we're going to rewrite that as 4 square root 3.
And we never gonna solve that.
So that is solved. We're not going to multiply 4 times the square root of 3 because then we'd have to round. So on this section, we're going to give exact answers.
Okay.
All right, and so the only way to get an exact answer here is to write 4 square root of 3. Shrug, take your headphones off and put them in your backpack, please. Anybody else that's got headphones, AirPods, earbuds, and Andre, will you take yours off your head? I know you don't have them on. So I can take them off. Some people will have them on when I let them stay there, Andre, so I'll try to be fair. All right, example 3. Short, long, height. These are the ones that are a little stickier. We know the length of the long leg. That's 6. The length of the short leg is unknown, and we're going to use x to represent its length. The length of the hypotenuse is unknown. We're going to use y to represent that length. Now remember, we don't have a relationship between that we've learned between the long leg and the hypotenuse. We've got to work with the long leg and the short leg. Y'all with me? So the long leg is, so that's going to be 6 equals, right? Equal sign translates as is. So the long leg is, in this case, is 6 is equal to the square root of 3 times the short leg. You do have to remember a little bit about how to multiply and divide square roots, but I am giving you a refresher, so don't sweat that. So, Mr. Murgatroyd, Batman, this thing is not going to work. All right, we're going to divide, hopefully my board is going to work so I can show you. We're going to divide both of these by the square root of 3 because we're trying to isolate x here, right? So if we divide this by the square root of 3 and divide this, why is this board doing this? By the square root of 3. I'm telling you, that's the square root of 3. So if you can't read it, just write what I told you. Divide 6 by the square root of 3 and the square root of 3 by the square root of 3. Square root of 3 divided by the square root of 3 is 1. So that's going to leave us x equals 6 divided by the square root of 3. Now, in a perfect world, we'd be done right now, right? But we can't leave a square root in the denominator. If you remember from algebra, you can't leave a radical in the denominator. Only radicals we had to work with like this were square roots, so we have done it before. So how do we get rid of that square root? Well, whatever that square root is in the bottom, you multiply the top and the bottom by that square root. So since it was the square root of 3 here, you multiply the top and the bottom by the square root of 3. So when you multiply the top 6 times the square root of 3 is 6 square root of 3. But you'll notice on the bottom, I have just 3. Why do I have just 3? Right. Well, they don't cancel. But if you multiply the square root of 3 times the square root of 3, you get the square root of 9. Do you guys remember that from algebra? What is the square root of 9?
3.
3. So that's how that is simplified to 3. The square root of 3 times the square root of 3 is the square root of 9, which simplifies to the square root of 3. And sadly, we are not done, but it's not hard from this point. We all know that 6 and 3 have a factor of 3 in common, right? So 3 comes out of that denominator 1 time, 3 comes out of that numerator 2 times. Just remember, the square root of 3 and 3 are not the same thing. They do not cancel, right? So our final answer here is 2 square root of 3. That is how long the short side is. So that's 2 times 1.71 something, right? But we're giving the exact answer by giving it as square root. Now, the hypotenuse is always 2 times the short leg. So 2 times the short leg is 2 times that coefficient, so it simplifies to 4 square root 3. That makes sense, Jamari? That makes sense, Molly? That makes sense, Jasmine? Makes sense, AJ? All right. AJ's Andre. I'm cool now. I know everybody calls him AJ except for me. I can't ever remember to call him that. All right. Caught up with me? All right. So, once again, beauty, we've got the short leg of 7. Can you guys tell me what the hypotenuse is? What is the hypotenuse? Right. So, if the short leg is 7, what is the length of the hypotenuse? What is that going to equal? What's the relationship between the hypotenuse and the short leg? Right. So, it's 14. That's right. So, the hypotenuse is 2 times 7, or 14. Way too little. All right. Now, the long leg. What is the relationship between the long leg and the short leg? Times square root? Square root 3. So square root 3 times 7, or 7 times square root 3, gives us 7 square root 3. This is a tricky one, so I'm going to let y'all catch up with me. Well, it's not that tricky. Well, it is a little tricky. It's just that there's going to be a few more square roots mixed in our equation. Right. But you have worked with these square roots in algebra. Short leg. What's the short leg? X. What's the long leg? 10 square root. Square root 3. What's the hypotenuse? Y. All right. We don't know the short leg, dad nabbit. We don't know the hypotenuse, dad nabbit. Those are the easier ones, right? But we do know the long leg, so that is the one we have to work with. When we work with the long leg, we always have to work with the long leg and the short leg. We learned the rule. The long leg is the square root of 3 times the short leg. So in this case, that's going to be 10 square root of 3 equals 3, the square root of 3 times x. So we have to isolate that x by dividing both sides by the square root of 3. See if this. Nope. Divide both sides by the square root of 3, and let me see if I can do it by hand. Ooh, just a little. Okay, a little better. What's the square root of 3 divided by the square root of 3? Let's say it again. 1, right. Anything divided by itself is 1. So that leaves us x equals 10 square root of 3 divided by the square root of 3. Well, that looks like it's going to be harder. But what is the square root of 3 divided by the square root of 3? 1. That simplifies to 1. So actually, the short leg is just 10. How do you feel about that? Good. I like that word. Good job, Misha. Interesting. You don't have to love it. I like it that you find it interesting. All right, once we know what the short leg is, so now we know the short leg is 10. So what's the long leg? Andrea, what's the hypotenuse? If the short leg is 10, what's the hypotenuse? So y is what's representing the length, but now we have enough information to find the number. So let's look back at the rule. The hypotenuse is 2 times the short leg. Well, now we know the short leg is 10, right? So what's the hypotenuse? Very good. 2 times the short leg is the hypotenuse. Does that make sense, Sejor? How you doing, Lee? Does that make sense? Lennon? So far, so good?
About that last.
Okay. Here or here?
Down there.
This one?
After getting 10.
Okay. So 10 is the short leg. We know the rule between the relationship between the short leg and the hypotenuse is the hypotenuse is always twice the short leg. So if we calculated the short leg's length of 10, we just multiply by 2 to get the hypotenuse. From here. So we add 10 squared root of 3 divided by the square root of 3. You simplify.
That's X.
So this is X, which is the short leg. Yes. All right, and looking a little bit more confusing, but it's really basically the same thing. Go ahead and draw yourself a couple little triangles that look like this. They're equilateral. That line from that top angle to the other side perpendicular to the right angle, that's an altitude. I'm going to start uncovering stuff because you guys, we've covered this. This is review. Equilateral triangle is also equiangular. If you don't want to write that, you don't have to. Optional. The altitude bisects the sides it's perpendicular to. If you don't want to, we've learned this before. You don't have to write that if you don't want to. But all that means is this line splits this side into 2 congruent parts. Remember? Bisect. By 2 sects parts. 2 parts. They have to be congruent. Vocab word we didn't talk about is perimeter. Anybody remember what perimeter is? How do you find the perimeter of a shape? How will we find the perimeter of a triangle? So, try to open your eyes and pick your head up, bud. So what is the perimeter of this triangle on sides 3, 5, and 7? The perimeter is a distance around, right? And in a 2D shape, we can just add the length to the side. So the perimeter of this triangle, 3 plus 5 is 8, plus 7 is 15, right? Perimeter, the sum of all the sides. If it's a rectangle, we'd add all 4 sides. If it's a triangle, we add 3 sides. If it's a pentagon, we'd add all 5 sides, right? This problem, they tell us the perimeter, and we need to find the side length. Normally, we might not be able to do that, except they told us specifically that we're working with an equilateral triangle, and we talked about that earlier. So that means all 3 sides are congruent. So if you add them all together and they're 54, and they're all the same length, we just take the 54 and divide by 3, right? That gives us the length of all the sides. Yes, that's an S for side length. Now, the altitude bisects this side, so if all 3 sides are 18, this one's going to be 9, and this one's going to be 9, right? So, we could use the Pythagorean theory here and solve for the length of the altitude, but we're learning about 30, 60, 90 triangles. So right now, it doesn't look like we have a 30, 60, 90 triangle because it didn't tell us that. However, that altitude splits an equilateral triangle into 2 congruent 30, 60, 90 triangles. How do we know that? Well, you guys, Jamari, in fact, told me that all 3 sides, all 3 angles, rather, measure 60 degrees, right?
Yeah.
So we also know, in addition to bisecting the sides, the altitudes bisect the angle. So this angle is being bisected. So that means this angle is 60 divided by 2, or 30. all three angles are 60 degrees. We know that this angle is 60 degrees. We also know this angle is 60 degrees, right? They're all 60 degrees. So now if we look at our diagram, we actually have two 30, 60, 90 degree triangles. So we're going to just use this right one here because I put the 30, 60, 90. So it makes sense. 9 times 2 is the hypotenuse, 18, right? So what we need to do is we need to find the length of this long leg. Well, we know the length of the long leg is equal to the square root of 3 times the short leg, right? We already know the short leg. Oh, I did that. We don't do it that way. So the long leg is the square root of 3 times the short leg. So the long leg, the altitude length is 9 times the square root of 3. That is the exact length. If we wanted to evaluate that square root of 3, we could round that. We're not going to. We're going to leave it just like that. Questions, Kendall? You good? All right, so this is another 30, 60, 90 degree triangle. They tell us now that the height of the altitude is 10. We know now this is two 30, 60, 90 triangles. So if this is 10, we need to know, we've already talked about that. The question asks us, what is the side length? Well, we don't know what the side length is, but we know that the side length this short leg is half the length of the side. Does that make sense to you? Because we just said that this altitude bisects this. So we know that this and this are congruent. So if we're looking for the side of the triangle, we're going to find this length, and we're going to multiply it by 2. Does that make sense, Tam? Does that make sense, Gerard? All right. So now, X is the short leg. We know the long leg. So all we've got to do is plug in. We don't like this one a lot, but that's all we got to do. So we know that the short leg, there we go, is equal, the long leg is equal to the square root of 3 times the short leg. Once again, we are going to be dividing both sides by the square root of 3. We just did this one. I'm tempted to just skip the whole computation, but I think this is our last problem, so we won't. So we're going to divide by the square root of 3. Divide by the square root of 3. And that's going to simplify to x equals 10 squared root of 3. 10 divided by the square root of 3. I'm going to do the exact same thing we just did. We just did this problem on the last one. So now we know, well, similar problems. So, yeah. So we're going to have 10 square root of 3 once we divide both sides by the square root of 3. Yeah, there we go. Now we're going to get the radical out of the bottom, so we multiply top and bottom by that square root. So 10 times the square root of 3 is 10 square root of 3. Square root of 3 times the square root of 3 is, what's it? It's 9, so square root of 9, so it's the square root of 3. So once we know that's what x is, that's half of the side length. So now we're going to multiply the side length by 2. So 2 times x, rather, that gives us the side length. So this is 10 square root of 3 divided by 3, 10 square root of 3 divided by 3. Multiply it by 2, and you'll get, I had that answer written. It's going to be 2 times 10 is 20. Square root of 3 divided by 3. Remember how you multiply fractions. Top times top, 2 times 10 is 20. Can't multiply inside the radical. And then bottom times bottom, 1 times 3 is 3. What's that? That's the final answer. That's the side length. 20 squared is 3 divided by 3.
Do we have two homework assignments tonight?
You have one.
So we have the paper one and the one, what's the one on
Just
that?
the paper one. You don't have an online one tonight. You have the paper one you picked up.
There's one on that. Is that for tomorrow?
That's for tomorrow. Yep. 8-1B is for tomorrow. So don't do that one tonight. We're going to do this one tonight while these notes are so fresh in your head. If you wait till Monday, you will forget it all. So definitely practice by doing this worksheet. So this one is not a mastery assignment. This one is a completion assignment. You need to show me good faith work on here. They don't have to be right, but they do have to have shown worth and all attempted and a good faith effort. Use your notes. Don't be a quitter. Don't give up. Try them all. Okay? And I will see you guys on Monday. So go ahead and scan and submit your notes.